Okay, sorry for the delay. So, I have the math here and I'm going to show you how to do the math. So, for my problems, I was given 10 milliliters and 5 milliliters and a molarity of 0.2 for the sodium carbonate and a molarity of 0.06 for the magnesium nitrate. Okay, so I know this unit is very new for you guys, but I recommend anytime we're talking about molarity, which is capital M, always write it as moles per liter. Okay, notice I did that for the first one, and I also did that for the second one. The reason why I recommend doing this, it's because it's always easier to tell how to cancel the units. So notice I was given 10 milliliters, so I'm going to convert that to liters first, right? So I got 1,000 milliliters in 1 liter, and then I'm going to use the molarity to cancel the liters and get moles. Why are we going to moles? Well, and I'm probably going to upset a few of you, but you're given amounts for 2 reactants. Does that sound familiar? It should sound familiar because it's a limiting reactant problem. So that means we have to do this problem twice. So we're going to take our first reactant. We're now in moles, and it's also we're going to convert it into moles of carbonate. So notice here, in 1 mole of sodium carbonate, there's only 1 mole of the carbonate ion. Okay, so that's what I have here. And now because this is a limiting reactant problem, we have to convert it into the product. So for 1 mole of sodium carbonate, we get 1 mole of magnesium carbonate. And the way I did this was because we had determined already the equation for this reaction. So notice, here is my equation. Sorry for shaking the camera. So it's a 1-to-1 ratio on everything. So for every 1 mole of carbonate, I have 1 mole of product. And for every 1 mole of magnesium ion, I have 1 mole of product. Okay, so that's the math for the first one. Then I'm going to do the second one. Okay, in this case we're given 5 milliliters, so I convert to liters and then use the molarity to get moles of magnesium nitrate. And then if we look at the equation for magnesium nitrate, for every 1 mole of this thing we have 1 mole of magnesium. Okay, of magnesium ion, sorry. And then I convert to the moles of product. Now we have 2 moles of product. I'm not going to show you the numbers because hopefully you guys know how to do this math. But if you're doing a limiting reactant problem, which is the case, you are going to determine the moles of both products. You're going to determine the moles of the product using both reactants, and whichever is the smallest is the limiting reactant. But we're not done yet because the question wants the mass. So once you determine the moles of the product, which are the smallest, then you'll take that and convert it to grams using the molar mass. I hope at this point everyone knows how to do that because that's a very important skill for this class. Okay, good luck on your homework.